Okay, so in this video we're going to talk about cold water supply to a home. So at this point we would have spoken a little bit about an introduction to plumbing, what it is, what it's all about, the components involved and the appliances involved, and we would have learned that there are two main reasons for supplying water to a home. The first reason is for domestic use, that is having hot and cold water for drinking, cooking, washing and whatever else is needed for any of these sort of appliances there. The second reason why we want to supply hot or cold water to a home is for a heating system. That is a line of water that's been pumped through your radiators to provide heat to a home. The focus of this video is for the domestic water supply, so that is your washing, cooking, drinking and so on, and specifically all we're going to focus on here in this video is cold water supply to a home. Okay, so cold water supply for domestic use. There's two systems used, or there's two systems that can be used for cold water supply to a home. We've got the direct cold water system. I've got a 2D schematic diagram of that. And we've got the indirect cold water system, which supplies water to a home, a schematic 2D view of that. I'm going to talk through both of those. We'll look at advantages and disadvantages of both, and then we'll look at sketches of both. So the sketches that we have here, just so we're aware, we've got kind of like the floors of a home in 2D format. We've got the ground floor here, we've got the first floor and the attic. All of these are the regular appliances that you would see in a home. You've got a kitchen sink downstairs. There may be more appliances, but we'll just focus on a kitchen sink. You've got a bath, wash hand basin, that's a sink upstairs in your toilet, and a water closet, WC, is your toilet upstairs as well. In your attic, you've got an attic cistern or an attic tank. And in your hot press or your airing cupboard or somewhere in your home, you've got a hot water cylinder. Now the function of this hot water cylinder is to provide hot water to a home, which is not what we're not too concerned about, but there is a cold line that goes into that. That's why we're including it in this diagram. Alright, now the direct cold water system, just to explain, what we have here is a main supply. So around your community, your estate, whatever road you live on, wherever it is, there is a network of pipes, mains pipes, whereby there is clean filtered water being pumped through from a water treatment plant in your locality, and that water is pumped through these mains pipes, very, very large pipes at high pressure. As this network of pipes goes through each community, each set of houses, there's a network of pipes which goes into each house, and that is pumped into under high pressure into each home. So the water is able to navigate its way through the plumbing system in a house through high pressure. In some cases there might be some pumps, individual pumps to pump it through the system, but generally high pressure, gravity and physics is what gets it through the system. Okay, so your direct water supply system, you've got that clean filtered water, comes from the main, that's pumped into the home under high pressure, and it goes directly to your kitchen sink, and it goes directly to every other appliance in the home. After that, it works its way up into the attic cistern and fills up the attic cistern. But this is called the direct system because it goes directly to each appliance first and then goes to the attic cistern. Alright, we've got a cold water supply which comes from the attic cistern down into the hot water cylinder also. There's some valves in this system, so you've got an on-off valve outside at the main source, so generally outside your home somewhere. You've got an on-off valve underneath the kitchen sink. Generally there's an on-off valve before the appliances maybe, but also there'll be an on-off valve at any bit of pipe work that goes in or out of the attic cistern, and those valves allow you to cut off certain parts of the system in case any maintenance or repairs need to be done. But the main thing with the direct system is the main supply, the clean drinking water, goes directly to all your appliances before going to the attic cistern. Okay, now just to look at the indirect cold water supply system, slight change to it. And the reality is it's a more popular method, it's what used. There are a lot more disadvantages than there is advantages to this system. That's why the indirect system is mainly what's used. We'll look at those afterwards though. With the indirect cold water system, the same layout is used for our schematic drawing. We've got a main supply coming in. The only appliance that the water goes directly to though is your kitchen sink. Alright, so there's a direct supply going to the kitchen sink. Everything else is bypassed. After that, the main supply goes straight up into the attic cistern and it fills up that there. So your clean drinking water, your main supply is up in the attic cistern. The attic cistern then indirectly supplies the rest of the appliances. So it'll set of pipework comes down there and it flows to your bath, your wash hand basin, your toilet, and whatever other appliances you have in the home, upstairs or downstairs. So it indirectly feeds your appliances, but directly feeds your kitchen sink. Alright, and you also have a line that comes down into the hot water cylinder as well. So the main difference between those is the direct system. It feeds these appliances, all appliances, directly under high pressure, which is the key point. And this one here feeds all the appliances indirectly except for the kitchen sink. Okay, so you can see the difference in the pipework there. The only difference is there's an extra bit of pipework coming down here with this system. Now, advantages and disadvantages. Let's look at the direct cold water supply system. Some of the advantages and disadvantages of this system here. Advantages first of all. This and this are kind of generally tied in together. It's easier to install, right, because there's less pipework, and therefore it's a lower cost. So you know it's easier to do because it's a more simple basic system. So it's going to have less of a cost, easier to install because of less pipework. Drinking water is available from all taps. Alright, so this is drinkable water coming from the mains, clean drinkable water. It comes up, it goes to the kitchen sink, your cold kitchen sink tap you can drink out of. Technically you can drink out of the wash hand basin or the bath as well, because that water is going straight to those. We'll talk about the indirect system and drinking water in a few minutes. There are your advantages. Now, the disadvantages are quite serious with this one though, which basically explain why it's not used anymore. Reduced pressure at peak times. Your main supply system here, right, again it's a network of pipes going throughout the community. It's pumped through at high pressure. Now, at peak times, maybe 4 o'clock till around 6, 7, 8 o'clock, when these appliances are all going to be used the most. People are home from school, people are home from work, you're cooking your food, whatever else. There's a lot more pressure and there's a lot more use of all of these appliances. If you think of your community, if every home in your community is using all of these appliances a lot more regularly, and there's going to be more of a demand on this supply, therefore it won't be able to keep up the pressure as much. That is, with this system, you would notice that the taps actually slow down at certain times of high usage. Okay, a high failure rate of fittings at high pressure times. Now, outside of high peak times, there's quite a high level of pressure coming from this main supply. That high level of pressure is hitting all your appliances. It's hitting your kitchen sink, your bath, your wash hand basin, your toilet, and whatever other appliances there. It's constant high pressure going there. That will put a lot of strain and stress on your components, your taps, your valves, whatever else. You're more likely going to get failure in those components, and more maintenance will be needed with this system. There's no reserve supply if the mains fail. So if the county council have to do work on your mains and they switch off this valve here to your home, and they have to do some pipework repairs in the community, you have no water in the home. You cannot use any of these appliances because the water is coming directly from the mains. You can't use the kitchen sink, the bath, the wash hand basin, or even the toilets. That's a major problem if the water is switched off for a few hours for county council repairs, which happens every so often. Right, and also there's a risk of backflow contamination with this system. With this system and the pressure it's under, there's something called backflow, whereby water can backflow from one appliance to another, as in the wash hand basin to the bath. Right, and that's not a major problem if it goes from there to there, but you could also have a situation where there's backflow from your toilet up into your wash hand basin, which isn't a problem, which you do not want. You do not want any water coming from your toilet into any other appliance, which is a major contamination issue there. So those disadvantages far outweigh the advantages with this system, and they are the main reasons why the direct cold water system, even though it's a lot more simple, is just not as advantageous. Alright, we'll just address some of those things with the indirect cold water system and explain why it's that little bit better. Alright, number one, that backflow contamination is not as big a problem with this because the pressure with these is coming from the attic cistern, and it's not as high and not as much a problem, so that's addressed straight away. There is a reserve supply of water if the mains fail. If your mains are switched off here for repairs for a few hours or for a day or so, right, you have a reserve supply of water up here. Now there is a supply of water in the tank on the direct system, but there's no way this water is not coming down into those appliances. With this system here, this amount of water can be used on your bath, your wash hand basin and your water closet, as long as that water is still there. Depending on how much use you have there, a few hours, a few days, you could get out of this tank here. So if your mains are switched off, you can still use your bath, wash hand basin, your toilet and so on. You won't be able to use your kitchen sink though, because that is being fed directly, but you do have a backup for toilets and baths and so on, which is important, obviously. There's a constant pressure on all taps except the kitchen sink, so that issue of the mains being less pressure through the mains at peak times will only relate to the kitchen sink. So you might notice your kitchen sink, the flow is not as strong during peak times, but your pressure from the water pressure from these is coming from the tank up here, so you should have a constant pressure on all of these appliances here. Okay, so they're the main, they're big advantages, they're very important advantages that the indirect system has over the direct system. The disadvantages, right, look, because it's a more advanced system, because there's more pipe work and there's more skill involved in putting it together, it is, there's going to be a slightly higher cost to it, which is normal. There's a large water tank needed. Now there's a water tank in my diagram of the direct cold water system, but that's sometimes done without a tank as well. Now a disadvantage here, drinking water is only available at the kitchen tap. This clean drinking water is coming in here and it's going directly to the kitchen sink, so you can drink out of that. Now you probably are aware in your own home that you've been told you cannot drink the water out of your kitchen sink or your bath or anything like that upstairs. The reason for that is it is still clean filtered water, but it's sitting in the tank. That could be sitting there for a couple of days on end. Now it's still clean and it's still filtered and it's perfectly fine for washing and so on, but it's just not advised to be drinkable because it could be sitting in there for a few days and it could be stale or whatever else, and that's why you can't drink out of your appliances upstairs. Alright, but in the main, the indirect system is a far more advantageous system than the direct system. Okay, so just to take you through a sketch or drawing up both of those systems, we'll look at the direct cold water system first. I have it just labelled there in the top corner, and I have my page laid out in a landscape orientation. I've got a red, black, blue pen, some pencils, rubber and some rulers as well, just to mark to draw it all out. I'll start off by just using my own judgment, a neat and tidy line across the bottom of the page to represent the ground floor, roughly halfway up the page. We won't overthink sizes too much, but again, as always, we want to be neat and tidy with our work. That'll be the first floor, and then we will mark off the attic here as well. Okay, I'll draw on some appliances now, like the diagram that was shown. Roughly this position, roughly this size. We won't overthink too much, but try and be neat and tidy with it. We're going to draw in kitchen sink in that place. We will, in roughly that position, roughly that size, we will draw in the bath. We will draw in the wash hand basin, freehand that, and we'll draw in the toilet or water closet as it's officially known. Symbols for all of those. I'll label in some of those parts there before I go any further. You've got the kitchen sink, the bath, we have the wash hand basin, water closet, I'll just label the attic and so on as well, first floor, ground floor. We'll draw in the attic cistern, roughly that size, roughly that position. Don't overthink it, be neat and do it right as well. Roughly this position here, we're going to draw in the hot water cylinder, which hasn't got a huge part to play in this diagram, but we're going to draw in the cold water supply into that system there, that cylinder. So attic cistern, and hot water cylinder. Okay, when you're drawing these diagrams, you'll be expected to be able to draw that layout all neat and tidy as well, so practice is what gets you there doing that. Now the direct cold water supply, so we're going to bring in a mains line underneath, blue pen to represent our cold water. Nice and tidy. I'm going to bring that up. So it's the direct system. So I'm just going to draw it straight up first of all to about there beside the tank, but this directly feeds into, it's a smaller ruler, easier to manage, directly feeds into the kitchen sink, and it directly feeds into all the appliances upstairs and downstairs, like so. So it's going directly here, 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 up there, and it's also feeding into the attic cistern there as well. Now, a couple of valves. There's going to be a valve to allow you to switch off that system outside your house, underneath the ground, if maintenance work needs to be done. There's also a number of valves around the system to isolate certain parts of it. So there's usually a valve underneath your kitchen sink if you want to do work on the kitchen sink, change a tap or whatever. There's usually a valve, any bit of pipe work going into that cistern, there's usually an on-off valve which allows you to isolate parts of it and do any repairs or changes that need to be done. We have just, it would represent some water in that attic cistern, ball cock valve, like that, which we've explained already. And then we'll have a line of cold water coming out of that tank, which goes into the bottom of the hot water cylinder. Hot water is another day's work. But that's basically that system drawn up, spoken about numerous times. There will be a valve there as well for any maintenance work that needs to be done there as well. Okay, so that's basically the direct cold water system drawn up and complete. We'll just go on there now and we'll draw the indirect system as well. Now for this sake of the video, I have just drawn everything out. You will obviously have to draw that out again yourself when you're doing it. But we'll bring in our mains supply. So we're going to bring our main supply in underneath the ground again outside your house, to about there. The indirect system, again I'm going to bring that line all the way up to the top for the moment. Blue pen to represent cold water. And the indirect system, the only direct supply is going to the kitchen sink. Alright, so we have that coming in here, coming up there, and it goes directly to the kitchen sink. It bypasses every other appliance and we fill up our attic cistern there. Ball cock valve. From there then, there's an extra bit of pipe work with this system coming out of that tank. So I'll come down here nice and low and across to every appliance. Now when we're crossing over pipes with our diagrams, we just do a little curve to show that they're going around each other or not through each other. And from there, we'll just draw our lines. And that's going to go into each of the appliances. Okay, so it's going up here, into there, and then it's coming down out of there, and up into each appliance from there. And same with the last system, we do have a cold water feed that comes down and into the bottom of the hot water cylinder. Couple of valves to draw in. You've got that valve outside your homes, you've got a valve underneath your kitchen sink, you've got a valve going in to the attic cistern or out of it for any isolation needed, so you can repair or change any parts of the system. Alright, so that's the two of those drawn up. It's important that we can get ourselves to a stage where we can draw those up neatly and correctly.